Well, hello again everybody. And as you can see on the bench today, we've got a capacitance resistance analyzer. And the model number for those playing along at home is the TE-46. Now, taking a close look at our CR analyzer here, I've noticed it doesn't actually have the maker or the manufacturer's name on it, but I have done some searching online and I believe that these were actually imported by Lafayette Radio. Now, if you're watching the video in America, I'm fairly sure that these were actually imported via the TV Corp of New York, but I believe they were also available via a variety of other names. Now, I'm fairly sure somewhere in the past I've seen exactly the same piece of equipment which was also manufactured under the name BK Precision, but I'm not absolutely certain of that. But I wouldn't be surprised if these were manufactured in Japan, and it could be that these came out of the same factory as Trio that I think went on to become Kenwood. Now, I also believe the approximate date of manufacture is probably in the 1960s, but again, not absolutely sure. Now, for those of you that haven't seen one of these before, it's basically an AC bridge, and you can use this for measuring the values of resistors and capacitors. But it's also got a few other functions thrown in to boot. Now, back in the day, before the ubiquitous and very low-cost LCR meters became available pretty much everywhere, the use of DC and AC bridges was actually really popular for working out values of both capacitance and resistances. And most of those old bridge-based instruments would typically have an analog center-zero meter. And they would usually have a large rotary control like this one, and the graticules on this, it's actually marked off in terms of ohms and capacitance values. And what you would do is you would adjust this big knob here until the actual meter, the analog meter, until the needle reached a zero position, and they would call that a null, at which point you knew that the bridge was balanced. But rather than having that rather large, complicated and therefore expensive analog meter movement with its center zero capabilities. But in this case, they've actually replaced that analog meter with a 6E5 Magic Eye tube. So the 6E5 Magic Eye class of tuning indicator, these actually originated in the US, and the type 6E5 was one of the earliest types to actually hit the market. And apparently almost all of the European types more or less copied the original American 6E5 type indicators. Now, historically, these type of bridges were available in quite a wide range of different specifications and quality. Now, some of those early bridge meters were items of absolute beauty and were manufactured to very high quality for very high precision work. Now, this one that we're looking at today, this is what I would call a service grade instrument. So this is designed to be used in something like a repair shop rather than a laboratory environment. So we've got a function select switch here at the bottom left of the instrument, and what you can select from, we've actually got four ranges of resistance values here, which go from about 2 ohms up to 200 megohms. We've also got 4 decades of capacitance ranges, and those range from about 10 picofarads all the way up to 2000 microfarads. So this capacitor resistance analyzer does also have some additional functions, and those include it can actually measure leakage within capacitors, it can measure dissipation factor, and it can also measure insulation resistance using this control over here. Now, another very important feature of this particular CR analyzer is the fact that it can actually test capacitors over a range of voltages. So hopefully you can see here we can actually go from 3 all the way up to 600 volts. Now, this is particularly useful if, like me, you like to work on valve radio equipment where you need to know the leakage of things like old waxy capacitors. Well, okay, I say you need to know. The reality is if you see a waxy capacitor, you just change it out on site because you know it's going to be leaking anyway. But in theory, the fact that we can actually carry out those leakage tests at a range of different voltages is really useful, and that's a big advantage over the modern digital capacitance meters that work at such a low voltage they won't actually show up faults in capacitors such as leakage current. Now, the fact you can go between 3 and 600 volts is actually a real benefit for the type of work that I do. When we're doing both the leakage and the insulation resistance test, it doesn't actually use a magic eye valve, it does actually use this little calibrated meter here. Now unfortunately, I'm sure that some of you will probably have already noticed that this meter is actually missing its plastic surrounding bezel, and this is how this meter actually arrived with me. So it is an absolute wonder, isn't it, that we managed to ship this via eBay and the meter does remain, or certainly it looks intact. Now thinking back, it was actually quite a few years ago, maybe 2 or 3 years ago, that I actually purchased this CR analyzer, and I think the main reason I bought it, I'm quite ashamed to admit, is it was very cheap on eBay. I think I paid about £5 for it, and I didn't have a lot of interest in it as a CR analyzer. I think I was probably just looking at the cost of the magic eye valve here and thinking, well, for £5 I couldn't even buy a valve for that, so I'll scrap it out for parts. But of course, although I did buy it potentially with that intention, of course now I've got it here, I think it's too good to actually do that with. So I think we should see if we can try to resurrect this meter today and see if we can actually get it working. I've got no idea, it hasn't been plugged in or tried, so I think we need to do that. But before I go any further, I'm just very cautious that this meter here and the little needle, it's very vulnerable, and it will just take the slightest touch on my part to just ruin it. So I think what we need to do is we need to put some protection around this meter. So what I've already gone ahead and done is, previously when I bought the meter, I did go ahead and I printed a new replacement bezel just to go over it like that, because the original piece of plastic was missing. So I think what we'll do is, at the moment there's just a hole in here, so we need to find a piece of plastic, and going to glue that on the inside of here, and then we'll glue that onto here, and hopefully that will protect the meter. I don't actually know if the meter even functions, but let's put this on it first before we dig any further. So previously I did go on to Amazon and I've bought this. I think that this is maybe some form of plastic sheet. I'm not sure if it's acrylic, I think it might be. And it's about 1mm in thickness. And I bought an A3 sheet of it. Again, it wasn't very expensive. So I'm hoping that we can cut a piece of this out and we can just glue it into our meter here. It does actually look a little bit opaque, this plastic, but I think it has got like a protective film on it that we're going to have to pull off. Well, I don't know what it is, it's a bit like buses, but I seem to go years without having any problems with meter movements. But in the last year, I think I've come across bits of equipment that have got 3 or 4 kind of smashed or defective meters. So it seems like repairing meters and you know, replacing the plastic on them or the glass seems to be something which is happening quite a lot at the moment. Now hopefully it isn't going to take too much glue to actually retain this thing. I wonder if I'll manage to glue my fingers together. I usually do. Okay, that's a little squodge of super glue. Can we get this onto here now? Okay, that looks okay. I guess I'm just going to have to leave this now for 15 minutes for the glue to set, aren't we? So let me go ahead and do that. Kind of wondering if just a little bit of weight on here will help it. So let's weigh it down with some coins. So the glue is set now, and I think that's going to hold our clear piece of plastic in the front of our meter. I think that's going to hold it fine. I think I'll just put some little drops of glue again around the circumference of this bezel, because it's not going to be able to use the original clips on the side of the meter, although I have made it to be kind of a fairly tight fit anyway. So again, I don't think it's going to take a lot of retaining. I'm just going to put a little tiny bit of glue on it, because then if the meter doesn't work, maybe I can take it off again. Okay, let's give that a go. I actually don't think that's bad at all. I have just noticed that unfortunately the meter's not exactly on its 0, but it's such a small and crudely reading meter anyway, that isn't going to matter. So on the front of the instrument we've got 3 terminals labelled A, B and C, and it's got a little link drawn on the side here which it shows that for measuring resistance you use the top two terminals, which is A and B, and for measuring the capacitance values you use the bottom two terminals, which is B and C. And actually the B has got a minus on it and the C's got a plus on it, and again the two bottom terminals are colour coded black and red. Now I'm guessing that's because you could use these to actually energise an electrolytic capacitor, and of course the polarisation is important because if you get it wrong it's possibly going to go bang or not work properly, especially given that these output terminals here, I'm guessing you can have as much as 600 volts on them, so that could be a little bit dangerous. You wouldn't like to lick them, would you? Now I'm not sure how well it's showing up on camera, but the whole face of the unit, it is actually looking pretty grubby, pretty dusty and dirty, so it needs a good clean. In fact, I think we'll unscrew all these. We'll take them off and we'll give them a good scrub with a wife's toothbrush, which of course you all know by now is a perfect tool for knob cleaning. And just taking a close look at all the knobs, they are pretty grubby, so I think they could all benefit from a go on the wife's toothbrush, so I think we'll get these pulled off as well and give them a good knob washing. Okay, at least it came off easily. Also just noticed we haven't lost any of our brights on the end of our knob, so that's good as well. I think we will also remove the main bridge balancing control here, but just looking at it I don't think we'll get this off because it's got this plastic pointer over the top of it, so I think we'll probably have to open the instrument up before we can remove this piece of plastic and get this off, and then we can give the whole thing a good clean. So just taking a look at the instrument, you can see it's got this really nice leather strap for carrying the instrument around with, and it is actually, in fact, yeah, it's a real leather, and it's got lovely hand stitched detail on it, so yeah, somebody's gone to some time and trouble to actually manufacture this. Now the paint on the unit, it seems in relatively good condition. Now it has got that what do you call it, wrinkle effect, crinkle paint, and the problem with that stuff is it gets dirt and crud ingrained into it. So again, I think we will deploy the wife's toothbrush and give this a particularly good scrubbing, and I'm sure this paint should come up quite nicely. We may even treat the leather strap here to a bit of shoe polish, one never knows. So just take a look at the back of the unit, it's really not very interesting. There's no manufacturer's label plates or any of that malarkey. In fact, the only thing we've actually got is the entry here of our 2-core cable. Now generally I will go ahead and I will replace these 2-core cables on site, and the reason being is because this is a metal instrument, and of course if we get a fault on the transformer, I'm assuming there's a transformer in here, if you get a fault on that transformer the case could become live and you could receive quite a nasty electric shock. Now there is some good reasons why you may choose not to earth the case of the instrument. You know, a lot of people always leave comments, oh you shouldn't earth it. Well, it depends on whether you consider the electrical safety is important or not. Now personally I do. Now some of you people live in countries where you get 110 volts. If you get a fault on something, your mains domestic supply is 110, 120 volts. Well, that kind of voltage, it's like licking the top of a battery, you can hardly feel it. But if you get a shock from 240 volts, you know about it. And so I think generally if you've got a piece of equipment like this, piece of class 1 equipment, really it's probably a good idea to go ahead and earth it. Now the instructions that I've got for this don't show us how to get into it, but I'm kind of guessing that if we undo 2 of these screws here, maybe the whole of the chassis for this will actually just push forward. So I'm going to try that first. Okay, I think I just detected a little bit of movement there. Is it loose now? No, it isn't. Okay, so yeah, we have released the back of the chassis, but no, it's not coming out yet. So I'm guessing we've got to release, again, all these screws around the perimeter of it. So let me go ahead and do that. Now from past experience where I've worked on similar pieces of equipment, I'm really not expecting to find very much in here. We're probably going to find a transformer, a rectifier valve. Obviously we've seen the magic eye. I think this will be some form of probably precision rheostat. Also the kind of things you'll find is we'll find a bank of precision resistors. and we'll probably also find a bank of, well, again, they should be precision capacitors, but I'm not exactly sure in this particular unit. We'll open the top and we'll have a look inside. Last screw, and then hopefully she's going to pop out. Okay, there she blows. Come on. Well, I think I had a fairly good prediction there. Let me just turn it onto its front. So let's take a look at the top side of the chassis first. So here's our Magic Eye tube, which is connected to a valve base. So it looks as though we can actually disconnect that, but looking at it, I can actually see that it looks as though it's actually been glued in at some point to the this rubber ring on the front of here. So maybe we'll have to leave that in. I can see what looks like something like araldite, some kind of brown glue around there. And I've also just seen that an elastic band has just disintegrated, so maybe this had a rubber band securing it as well. I'm not exactly sure. We've got a transformer here, a little bit dusty. Here's our main rectifier valve, which is, for those playing along at home, it's a miniature valve, it's a 6x4. Here's the main potentiometer for balancing the bridge, so that's connected to the big control on the front here. Hopefully you can see that. There's our analog meter movement, and just looking at our analog meter movement, I can see that there's no components on the back of here to protect the movement in the event of you know, an accident happening, if it gets over voltage or something like that. So maybe a little mod we can do while we've got the thing open, maybe we can add a little protection circuit to this meter. I'm not sure, we'll take a look at that. We've got a fuse, which is, I don't know, let's have a look. Yeah, I think that's a 1 amp fuse. And you can also see we've got some, what I'm guessing is quite a few precision resistors, which are actually used on, what are they used on? Okay, so it looks as though it generates the actual various voltage outputs from 3 to 600 volts. I thought it might have been using tap-ins on a transformer, but it looks as though all we've actually got is a range of resistors, so I'm sure it's got some form of potential dividers using these resistors here. So that's how it's going to divide the voltage down from for example, from 600 volts to closer to 3 volts. So that's done via resistances rather than via transformer tap-ins. Can we just turn it over gently? Let's have a look on the underside of the chassis. So just spotting the underside of the transformer here, it looks as though certainly one of these must be an across the mains capacitor. Now these look like little cans, so they look a little bit like electrolytic capacitors, but in fact they aren't electrolytics. What these will be is they will be paper capacitors that have got a metallised can around them. Quite often these actually do last quite well, but we should probably change them out, and especially the capacitor that's across the mains, that really should have the correct X-rated capacitor on it. So we will go ahead and see if we can find something of that nature. So I'm guessing that these two large capacitors here, which are, I think they're 10 microfarad each at 350 volts, they've actually wired them in series, and I'm guessing the reason they've done that is because this unit is actually capable of delivering quite a high DC voltage of over 600 volts. So obviously they couldn't get the working voltage within a single capacitor, so what they've actually done is they've wired two capacitors in series to try to make up to the 600 volts that they need it. So 2 times 350, in theory that's 700 volts, but generally it's not necessarily such a good idea to wire capacitors in series, but I guess there's only 2 of them, so you probably would get away with it. Again, I can see we've got some precision resistors on here. I can also see on this range selector switch we've got various precision resistors, and we've also got at the back, I can see that we've got, it looks like a miler capacitor, which is over here. And I can also see that we've got a 0.4 microfarad, and it looks like a 4 microfarad, and to me that looks like a precision capacitor. So again, it says on it that, well, working voltage 100 volts, but it's 4 microfarads plus or minus 2%. So yeah, some of these capacitors certainly seem to be used for balancing the AC measurements for measuring the capacitors. So yeah, so we've got a series of precision capacitors in here. I guess it's questionable whether or not we should replace some of those precision capacitors, but it's fairly irrelevant at this time because I don't have anything that's good enough to replace them with. I think we'll start off by changing these two electrolytics that are wired in series. Now I've got no idea whether they are bad or not, but usually I will just change out old electrolytic capacitors kind of on site. Now you can't always be sure, but I always say the life of an electrolytic capacitor is 10 years. Very much depends on how much the equipment has been operated, and probably more importantly how much heat there is around these capacitors, because the failure mode is that the electrolyte inside, the moist electrolyte, that dries out, and then the ESR, and you have other problems with them. Yeah, they've got quite a lot of voltage on them, 600 volts plus. I think we should change them out. Maybe once we have changed them out, we can actually use the actual meter itself to test them for leakages. That might be an interesting experiment. Now the way that I'm going to remove and in fact reinstall the new capacitors, I think that I'm going to J-hook them in, and the reason being is because these capacitors, they actually go onto a selector switch on the terminal strip, and my experience is if you actually start messing around with the very thin wafers on these selector switches, what can very easily happen is you can end up breaking the switch contacts off. I want to avoid that at all costs. That would be a very bad thing to happen, so I would rather be a little bit ugly and J-hook them in than risk damage on them. So these are Lily brand capacitors. Well, I've got to admit the first capacitor's looking pretty good. This has got 11 microfarads, 11.1 microfarads, and that's coming up with an ESR of 1.7. Typically for a 350 volt working capacitor, we could probably be up to 5 ohms of resistance for an ESR. So this is really very good at 1.7. Let's see if we can just check the other section of it. 10.7 with an ESR of 1.4. So again, that looks pretty good. Let's just test our new, I'm going to say no name, these are our RS Pro capacitors in the Jacon brand. Let's see what these come up with. Well, interestingly enough, our new capacitors actually measure worse in that they've got 2 ohms, 2.7 ohms of ESR, and they're only coming up as 8 microfarads in capacitance. Let's try the other one. Again, 2.7 ohms and 8.5 microfarads. So again, these aren't measuring, the brand new capacitors aren't measuring as good as the old ones. So that's a little disappointing, isn't it? The problem is though, you know as well as I do, if we hadn't have changed these capacitors out, the moment we just switched it on, the thing probably would have exploded, because that's what happens when you don't change the capacitors out. But yeah, I've got to admit, I'm feeling a little bit disappointed inside now. Now I've got to admit, I'm actually fairly dubious about using this Jacon range of RS capacitors. The only reason I've really gone ahead and purchased them is because when it comes to the higher voltage variations, 300 and 400 volts, I wasn't really given any choice to buy them from, you know, a more established or a more prestigious brand like, for example, Panasonic. Well, I usually, when I can, buy Panasonic capacitors. Of course, there are other manufacturers of capacitors out there, but I do think it's a little bit disappointing from RS Components that they are kind of pushing this budget brand above what I would call, you know, some of those premier capacitor providers. Yeah, I think that's a shame, RS. You never know, my conscience might take the better of me, and we may order some better quality 450 volt capacitors. But some of the high voltage electrolytics, they are getting hard to buy now in the UK, and I have started importing more and more from DigiKey in America, but it does make the whole thing just that little bit more expensive. Well, I was hoping to finish upgrading these capacitors today and quickly move on to giving this thing a little bit of a test, but unfortunately I've been a little bit stumped. Now the problem that I've come up with is there's a capacitor here which is actually connected between the actual live side, so the actual supply, the mains 230 volt supply, and it's connected between the live terminal of the transformer, and it's actually connected to the chassis. of the piece of equipment. But unfortunately the chassis of this equipment isn't actually earthed because it is only connected via a 2-core cable. So the problem is, if this capacitor does develop any leakage, we're actually going to form a connection between the 230 volt supply in the case here, which is going to make the whole piece of equipment live. So taking a close look at the capacitor in question, it looks like it's a Lily brand, and it says it's an oil CP-A, and it's 0.05 microfarad, which is I don't know, it's 47 nanofarad in modern money, and it's a 600 working volts DC capacitor made in Japan. Now the idea of actually connecting any capacitor between a live terminal and a piece of metalwork that, you know, isn't earthed, to me that just seems exceedingly dubious, because any type of failure is going to make the whole enclosure potentially live. But I guess it's even worse given that these capacitors are probably getting on for 60 years old. Now I've just had a quick look through my capacitor selection, and really if you're going to be connecting a capacitor between a live terminal and a chassis, it has to be what they call a Y suppression class, which is suitable for connecting between a live terminal and an earthed terminal. But again, unfortunately the actual enclosure itself isn't earthed. So I think one of the first things that we will need to do, and I did mention it earlier, is that I was going to disconnect this 2-core mains cable and replace it with a Freecore mains flex that's actually got an earth in it. And now we have found this problem with the fact that with this capacitor connected to the chassis, I think it becomes much more important to make sure that the chassis of this equipment is properly earthed before it's powered up. But unfortunately, having gone through my component bins, I've got quite a few of X-rated capacitors which are suitable for across the mains connection, but I haven't got any Y-rated capacitors, so I'm afraid I'm going to have to stop here and probably place an order with RS. Although I'm tempted just to earth the chassis, in which case if we do get a fault with the capacitor going slightly short circuit, or in fact just leak it, all that will actually happen is it will trip out my 30 milliamp circuit breaker. So maybe that's what we'll do. We'll go ahead and just replace this flex here with a free terminal and earth the thing before we plug it in. Yeah, let's try that. And assuming the thing does power up without exploding, what we can do is at some later date, stroke never, we can come back and replace this with a correctly rated Y capacitor. So as I just said, we are going to go ahead and we're going to replace this mains flex with a Freecore cable so we can earth the equipment. But before we do that, we might as well have a quick go at plug fuse bingo. But we're not going to reuse this plug because it is so old it doesn't actually have the shrouding on the live or the neutral pins. So we're not going to use this old plug anyway. So let's just open it up and see what fuse it's fitted. Now I'm going to start the bidding today at a 13 amp fuse. That is my guess that this has got a 13 amp fuse in it. Turn it round and going to do the big reveal. Oh, okay, 3 amp, I was wrong. So I guess that's at least something. We've got a 3 amp fuse rather than a 13 amp fuse, so that's a little bit safer. Now of course the main reason for replacing this cable is because we want one that's Freecore, but I actually also don't like this style of, again I'm going to call it American wire. To me this looks like bell wire in that it doesn't have any outer insulation. Of course the live and neutral wires, they are fully insulated, but I do prefer my cables to have an outer jacket on because it just gives them just that little bit more protection against any kind of abrasion. If you get any abrasion on this, you're directly going to start cutting in and exposing the inner conductors, whereas if you've got an outer sheath, well you've got a good chance of spotting this damage to the outer sheath before it actually cuts through. Now I've also just spotted another thing that I don't like about this wiring arrangement. Again, because this is a 2-core cable, and I'm guessing the design of this equipment was really based on the American market where their plugs aren't actually polarised. You can actually plug the socket in both ways. So depending on which way you plugged it in, either the live side would be connected to the switch and the neutral will be connected to the fuse, which is at the back of here. Or if the plug was in the opposite way around, the actual live side would be connected to the fuse and the neutral side would be connected to the switch. Of course I prefer for my mains wiring, I prefer to actually have the live side connected to the switch so that we're actually switching the power actually on and off to the device, and I also prefer to have the fuse in the live side rather than the neutral side, because one of the problems with having the neutral supply connected to the fuse, if you actually get a fault to ground, a live connection to ground, what will actually happen is the actual positive wire, the live supply cable, isn't fused if the fuse is in the neutral connection. So you can pass an awful lot of current to earth. And in fact, rather than the internal fuse blowing, what would actually happen is we'd be relying on the 3 amp fuse in the plug. Now kind of that's okay to some extent, but you know, what's the point in putting a fuse in here if they don't bother to fuse the live supply? As I say, the reason they haven't done that is because for an American plug, this was obviously designed for the American market, the plug could have gone into the wall in either direction, so yeah, there's no such thing as polarization. So I had a rummage through my junk box and I found this old Freecore cable, which I think is probably from a long defunct laptop power supply. So what we're going to do is we're going to repurpose this cable, we're going to cut the strange connector off the end, and we're going to wire this into our capacitor analyzer. Goodbye everybody, the time has come. Now before I go any further, I absolutely must just thread this through the back of the enclosure, because if we forget to do that we will be in trouble, because it's got a plug on one end and that isn't going to go through this little hole. Will this cable fit through the original grommet? No, it won't. Even if I try to apply some force, it won't. So a little bit of a modification is going to be in order, isn't it? And a little bit of lubricant of my choice. So we're going to fix our earth terminal onto here. Now perhaps some of the mains wiring looks a little bit confusing, because you appear to see the mains wiring going to multiple places on this selector switch, but actually it's not as complicated as it looks, because a lot of these terminals on the side of the selector switch, they're not actually connected to anything on the switch itself. They are just terminals which are being used just for the purpose of anchoring some of this mains wiring. So it looks like the mains comes into the switch here, and this is a main on and off switch. So it comes into here, and one side immediately goes into the 230 volt of the transformer, whereas the other side of the mains wiring, the neutral wire here, the neutral wire actually goes into the fuse. And of course, I said earlier, we don't actually like that, because we don't want to have the fuse in the neutral circuit. That's just not good, is it? So I'm just going to disconnect some of this wiring and see if we can clean it up a little bit. So I've got to, first of all, I've got to very carefully just connect the mains wiring to this terminal here on the switch. And unfortunately this is one of them where they've actually wrapped the wiring round just to make it that little bit more awkward, and more likely that we're going to end up breaking the switch contacts off, which we don't want to do. So there's a bit of snippy snip snip. So these two white wires here, these are the live and the neutral that are going to our transformer. So this wire that I've just cut off, this is just going between the neon and I think a 5k resistor there. So literally that's just the dropper resistor for the neon, I believe. I don't think it's connected to anything else. And I think we'll go from the switch side of the mains. We're going to go into the neon, but I think we'll also go directly into the fuse as well. So I need to reroute this to the fuse down here. I'm not sure if you'll be able to see it on camera, but the actual tag strip for the fuse, where it actually comes through the metal enclosure, it's actually pretty much touching the metal of the enclosure. There's less than a millimetre gap between the live terminals and the chassis here, so that's certainly no good. So I think at some point we need to change this fuse holder out quite urgently, but I'm going to see if we can just get away with leaving it just for now. And what we'll do is I'll come back and I'll change that out separately. So I'm going to leave some of this mains wiring relatively long, because I think we'll have to come back at some point in the not too distant future and you know, tidy this up a little bit more. So I think I'm going to use this tag with a resistor on. I'm going to use this as a common neutral point. So I'm going to supply our neon indicator here, and I'm going to put the actual dropper resistor in the neutral circuit rather than the live wire. It'll work just the same. And I'm going to use this bottom tab here to connect the neutral on the transformer to the actual neutral supply line coming in. So So let's go ahead and just loosely reassemble it into its case. There we go. For all that, I think we're finally ready to give it a first test. Let's switch on